exactly video on demand and OTT. So of course, it's pretty like the difference between OTT and video is like there is a very small difference and there is a very thin line if you're not having kind of understanding about the uh, video on demand and the OTT platform. Mostly like if you don't have any kind of a video background, then there might be a confusion between these two terms. So so VOD, as this picture depicts, it actually allows you to play the content wherever you want, right? So you want to play in morning or night, or you are while you're traveling or in the plane that time. So that's how the video on demand plays an important role. Whereas in case of OTT, it's kind of a platform where you can use the internet, but it's not like in your hand when you want to play. I'll cover more in detail in next slides. So let's try to understand how exactly you'll understand whether it's OTT or it's a VOD. So this like uh, flow that I have created will give you a more detailed idea about when you want to try to understand what is OTT and what is VOD, right? So for the first question, if you see here, so let's say there are two factors. One is if the video is played over the internet and whether it's played over the satellite. So if it's over the internet, then you can just ask this simple question like it plays on demand, like whether whenever you want to play, then it's VOD and OTT. You have the best example is Netflix, right, or the YouTube. So you can play it whenever you want. Just open the computer, the mobile app, and you're good to go. And if it's like kind of a live streaming where you have fixed schedule for it, then it's kind of OTT. It's not a VOD. Live streaming in any sports match, or you're watching any conference or something, right? So that's kind of OTT. And when it's actually streamed through the satellite, will that be again like the same question? Will that be like played on the demand? Then if VOD, otherwise it's not the VOD as well as not the OTT. Hope that clarifies the concept behind OTT and the video VOD. So let's move to the next slide about challenges. So I'll go in detail about what are the challenges and any application developer or any architect or any video application platform person can face. Even if you're a cloud architect or even a mobile application developer, these are the challenges you need to tackle efficiently. So one of the biggest challenge in current age, right? So there are tons of devices in different formats, whether it's Alexa, whether it's a tablet, mobile phone, or whether it's a TV, which have different operating systems, whatnot. So there are tons of devices, and your platform, what you're building, it has to be served on this platform so that you can actually easy so that your users can actually play that content, right? So so this is one of the biggest challenges. So to tackle that challenge, we need to make sure we are supporting all majority of the platforms, if not all. So I'll go to the next slide where I'll tell the major challenge. So each platform, whether it's a mobile app, whether it's like desktop, tablet, with or TV, right, television. So they actually need different kind of a codecs, so transcoders you can say. So this codecs like in if you're talking about a decade back, the last decade, the one of the major codec that was MPEG and H.264. So these are the best the H.264 was one of the having the best compression technique, so that the bandwidth of the user using was less and compared to the other codecs, so that was more efficient. But now like in the current industry or the current market, there are different codecs which are available, which are more 30 to 40% more having more compression techniques than the H.264. And as I mentioned earlier, more the devices, the more the codecs will be. Again, never know. Tomorrow's new device comes, a new codec might be supported on the device, and H.264 might not be easily supported. So that was currently widely used, but I'm just giving the idea that in future that can happen as well. So it's very important for any application developer who is building or architecting the video streaming platform. They have to adopt the new generation techniques or the compression techniques. So otherwise, their application might not be useful on the different devices or the new devices that are coming in the market. So this is one of the biggest challenge. So and that was actually early days, like as a developer, there's a team, like they have to convert all the videos in different formats and then upload on the cloud server or the dedicated server and serve them based on the device there. So that's kind of a pretty complex thing they have to handle apart from the application side of things. So it's architecture wise that was getting more complicated. But now like things are much easier. I'll show how using AWS cloud. That's pretty like straightforward nowadays. So, so these are major challenges as I mentioned, right? So I'll tell you what about the best practices when it comes to the media streaming. So when you're creating a media streaming platform, what are the best practices one has to follow? If you're an architecture or developer, just make sure that you're following these best practices. So as earlier as I mentioned, encoding, right? So encoding is one of the important parts when you're creating any kind of a streaming platform. Make sure your videos that are encoded in supports the majority of the devices available in the market today. As I'm given the example of H.264, right? So that is one of the best compression techniques used since long. And if you see this table, the H.264 is supported by majority of the platforms: iOS, Android, Windows iPhone and the Xbox, then Roku devices, the PlayStation, and the desktop. So majority of the desktop browsers support H.264. So this is one of the great format to use if you're creating any video platform. Then make sure your videos which you are uploading for the end users are in this format so that they can be easily served, and of course they can be easily decoded and played because majority of the platforms support it. Another important part here, if you see this in table, that the delivery protocol. So HLS is one of the famous protocol that is used widely for the better streaming, less buffering time. Because if you go with the traditional streaming apart from HLS, then it's more like you have to, the end user, right, whether it's a browser or the mobile app, they have to download whole video, the chunk of video to play, to start the playback. But in case of HLS, the each stream is divided in small files, like for example 10-second files. It's called .ts files. The extension of the file is ts, and these files are actually combined together, stitched together to help to play in the browser or in the mobile app, and it's widely supported now. So it's pretty famous, and you can easily convert your files to HLS format with the H.264 encoding using different tools available. I'll also show that how you can do that on the AWS cloud. So one other important practice that one has to follow is that making sure each video that you're creating, right? So in the assuming that you're creating in HLS format, the format will be like .h264, and then encoding format is just 264. So those video formats you have to store in at a single location. It's very important because each file that you're converting, it has to be served to multiple bandwidths, right? So for example, there is a video that you're converting, then you have to convert in different bandwidth bit rates as well. So for example, if someone is on 3G network, then he should be getting the low quality video at the start so that the buffering time is less, right? So that way, like you can easily, they can easily quickly start the video and start the playback. When it comes to the like kind of a high bandwidth network like 4G or LTE, they might be getting HD video, right? So each video is converted in different bit rates, and those should be stored in one of the single location, so that the content delivery that you're doing is from the single location, and you are not storing the copy or replicas of the videos, so that the storage cost will be less, and it will be served in more efficient fashion in terms of the management as well. So another important part, right? So once the storage is done, you have to make sure that you are using the right CDN. So in order to serve the video from the nearest location of the user, of course for the better latency, it has to be served using the CDN techniques. So one of the best part while choosing this AWS CDN, that they are actually the AWS CDN is available all over the world. Most of the regions they are supporting. So if you are choosing any CDN apart from AWS, then you have to make sure that you are covering these 4 points. One is global reach, which as I mentioned, AWS has. Then second is high performance delivery, right? So there should not be any kind of a performance issue when it comes to the delivery. There should not be downtimes, the latencies and stuff like that. Making sure they have they are like supporting in all regions as well as in a best possible manner. Third, one of the important aspects is context aware. So it's not like that the CDN platform is just acting as just end user end CDN, right? But they should be aware of like what kind of files and stuff they're serving to the end user, and of course understanding the end user's uh, like capability or location as well. And another most important part to improvise your platform as we move forward and as you scale is to understand the analytics side of things. So you need to access the logs of the users, what they're playing, how much time they're playing, and then from which location they're playing, which video they're playing the most, or maybe are they having any kind of lag, are they having any kind of buffer time. So these statistics will help you to improve your platform and user experience. Otherwise, if you don't know the end user statistics, like which users are coming and like just playing the video for next first 10 seconds and going out, or maybe they are not able to load the video for first 5 seconds, maybe there will be more bounce rate or something like that, then uh, that's not a good user experience as well. So it's very important for any streaming platform to get the analytics and then act upon it using this technique. So of course, CDN should provide them more detail and granular analytics. So that's the goal. And as I mentioned, like, so apart from CDN, there are other tools which can help you to measure the different analytics stats. One of the analytics is if I am building any kind of a streaming platform, so I want to understand bitrate is bitrate, because uh, this is one of the important metrics for me, because it helps to you to understand the quality of the video the user are experiencing. So what kind of bitrate they're getting, what kind of bandwidth they have, and what kind of a quality they are getting. Another second aspect that I mostly measure is buffer fill. The buffer fill is nothing but the time the user has spent filling in the buffer at the start, right? So it's like when you load the video, how much time a user has waited to start the video until the videos get started, right? So this is very important for to understand the bounce rate and why exactly people are not watching, or maybe they are coming on the page but they're not watching the video. So this aspect will help you. The stat will help you to improvise the platform further, maybe create more like low quality videos, or maybe like having uh, different instead of like 10-second size of the TS files, it can be 5 seconds. So that can be another way we can look at it. And then another thing is the lag length, right? So lag length is nothing but once that buffer is filled, right, and once it is finished, each user is again waiting for buffer to get filled. Then again there is a problem, right? So then that means there is no kind of, we need some kind of fine tuning between that like creating those TS files. So it's nothing but like the so buffer filling, so lag length is together it is called like kind of all the time the user has spent waiting. So that is very important metric. At the end of the day, you need to collect and understand how much time his user is waiting to in between the playbacks to uh, again like to resume the video. Then another important aspect is the play length. So that is one of the statistics is you need to understand to manage your data center properly, like your cost. If you want to increase your like say servers or whatnot, if you're like storing the videos on like for example EC2 platform. So so that is one of the stat. It will give you actual data streamed throughout your data center, out of your data center. It's kind of a bandwidth out, you can say. So how much data flowed out of your data center. So that is another important aspect I want to collect when I build any kind of a video on demand platform. So so these are the kind of a basic things or the best practices one has to follow when they start creating any kind of a VOD application. So let's start with one of the example like I created, and then I'll show you what all things you need to do if you're using AWS platform. You can also do at your end as well. We'll share this presentation, and then you can follow the steps as after the presentation. So so assuming you have some basic idea about AWS platform, these are the major services I'll be using today. I use in actually my demo for creating the video converter job. So if you want to create a media streaming platform, these are the services most widely used. One of the S3. So S3 is mostly used for the storage. So as everyone knows, like it's just kind of a it stores, it's just like a hard disk. It just stores your, dumps your data in whatever format it is. So we'll be using S3 for storing our videos, the videos that will be uploaded and the videos that will be converted in different codecs. So to convert these videos, we'll be using Elemental Media Convert platform, the service AWS provides. The serve the videos, we'll be using CloudFront, which is a CDN, as I mentioned, and then the other services around will be there. So IAM is one of the service where we'll be using for identity and access control. So these are the 4 basic services we'll be using today for creating a like kind of a video streaming platform. So as I mentioned, S3 is pretty straightforward. It's just used for the storage, and it doesn't have any kind of restrictions. Another one of the important part is like it's in terms of the data transfer is pretty easy. You can sync your data from any of the platform. If you have any kind of videos, even in like kind of a terabyte or whatever size, they have different ways to dump that video from your storage to the S3. They have pretty great infrastructure on that. Also, it has a compliance by capabilities if you want. Like I know like there are such platforms where healthcare or any other domains, they need some kind of a compliance, where it's a government as well, right? So they need compliance, and the S3 provides pretty good compliance capabilities for storage, the archival, then retrieval, as well as understanding who access which video or which file at what time and whatnot. Also, the security is there. Of course, the security is also there. In terms of the availability, it's almost available all the time. I haven't seen in my last 10 years that S3 was down for any reason. And it's almost like it's kind of a scalable. We don't need to worry about scalability at all about the storage compared to their other service like EC2. If you're storing something on EC2 platform, then you have to worry about your own storage. You have to increase the storage, stuff like that. But in case of S3, it's pretty automatically scaled. You don't need to worry about it much. So let's start with S3 and then understand how exactly the conversion happens, right? So if you see the screenshot, right, I have created one bucket called Media Convert bucket under the S3 in the East 2 region. You can create your bucket and you can choose any region. I had choose like East 2, like it's sort of one of the nearest region for me. So I selected that. After that, like in under the same bucket, I created a folder called output. So this is where our video that we're going to convert using the service, media convert service, will be stored inside this folder. So I created another folder inside the S3 bucket. So this is the file that I uploaded. So I have uploaded this file manually under the S3. So this is the kind of a Google ad I just uploaded in MP4 format. It's just 2 MB file. So one of the important aspects, right, in when you're architecting any backend solution for the video platform, so these files may be uploaded by user, these files may be uploaded by someone else, maybe like admin or any other person within the organization or end user. Like in case of Netflix and stuff, of course they must be having their own admin panel or something where they are uploading the movies, and end user is just watching it, right? So this architecture is not part of this scope, but I'm just giving the idea that you can use AWS API, service APIs to upload files from your platform, backend platform, the front end, or whatever. As soon as you upload to the S3 bucket, those will be actually served to the backend. Like we can understand as soon as the upload happens, and we can trigger our job. So that's again can be configured and can be discussed in later series. But today I'm just giving an example like with the input, one of the existing file that I have uploaded. So let's come to the elemental media convert, which I told. So now we have the file uploaded, right? So now we'll be using the service media convert to transcode the input file that I had uploaded, which is in MP format, and to convert in whatever formats we want. So this is the pretty straightforward job the service they have provided. It's just like a matter of few clicks and your video will be ready. So that's how simple it is. Otherwise, if you like talk 10 years back or something, this is kind of a pretty hectic job, right? So you have to use some kind of a command line utility, for example, OpenCV or something, right? So, or FFmpeg is one of them. So you can use FFmpeg, create that input file, and give the command line tool that file, provide the configurations, convert in different formats, store it somewhere, and it's not like handle the failure, scalability, everything you have to handle. But today, like using media convert along with the S3, it's pretty straightforward. I'll show you how. So this is how exactly it works. So source content is nothing but the S3 input media that I have given. We have to give to elemental media convert. It converts in different formats, whichever we want. So we can configure that. I'll show you how. And it stores back to the output folder, which I created under the S3. And once that is done, your video is ready to serve through CloudFront. It's pretty as simple as that. So let's go to see how I can do it. So this is the elemental media convert page where I have just clicked on create job option. So under that, there is an option to create a job under media convert. So the first part of this job is to input file, right? So which file I need to convert. So I can easily provide the path that I just given, right? So you can just browse it, or you can just select that file of just copy that path here and provide that. So assuming that is done, I have selected that, and then if you see, I have just clicked on browse, and the bucket I have selected, and under that I have just given that my file is Google Ads.mp4 is present in input folder. So I just selected the file. So now the second part. So if you see on the left side, there is output groups. So output groups, you have to create groups for the output format you want, right? So for example, you want to create HLS format for Apple, right? Apple HLS format. So you can just select that. You want to create different formats, you can just select another output group. I'll show you one of them. So these are the different output groups AWS supports, media convert supports. So for Apple HLS is one of the most format, like kind of a standard, which I told. We can just convert into the HLS format, and it will be served to majority of the platforms. Even the Microsoft Smooth Streaming, right? It can be also used to create smooth video format, but it is again under the pro plan. So you need to be a pro AWS user to use that service. And of course, like it's not currently it's not supported on majority of devices. So I just selected Apple HLS. You can add multiple groups as well. Just need to click multiple times on the add button. So for this, I created an Apple HLS, and if you see, Apple HLS has a standard encoding H.264 and AAC for the audio. So if you see on the left side, it has automatically selected that. So now after that, I have to select the destination, right? So if you see the destination which I created earlier, the output folder, I have just selected that, and under that, all the files that will be converted will be stored. So again, we can control this job again in more detailed way. Like under, if you see at the bottom, there is a segment control, which is nothing but how many, what is the length of the segment, each segment, like for .ts file, which I mentioned earlier, what will be the length of it? 10 seconds, 5 seconds, 20 seconds, depending on the length, the end user will going to get that video quite faster, right? So if it's 5 seconds, the 5-second video chunk will be very, very small, and it will be loaded pretty quickly. So those will be loaded asynchronously and combined together to play within the browser, within the mobile app, or any other platform. So this is the setting I did. Now there is another setting under the H.264. So if I select on the left side the codec H.264 and AAC for the audio, so there are different options which I can select. Like for example, the preset I would say, right? So there are different presets I need to select to make sure that my video is getting converted in different bit rates. For the like high bandwidth users, it can be like HD, right, or 4K, or maybe like for low bandwidth users, 2G, 3G, then that can be like a smaller video, or maybe low bandwidth video, right? The quality might be hampered, but that's how like the experience also matters in terms of the latency. So I can select multiple presets here, so that multiple format videos will be created, multiple bitrate videos will be created under the output folder, and automatically based on the user's bandwidth, it will be served through the CDN network. Again, that is not part of the today's presentation, how that dynamically can be served, but it's pretty straightforward again just like we need to provide only one HLS file URL to the end user's player, whether it's a mobile application or the web. It's just like dot HLS we need to M3 UAT we need to provide, and then the browser or the player will take care of which bitrate file I need to pick. So that those settings is actually automatically taken care by the end user's platform or the end user's player, I would say. So you can select a preset. Maybe we can select multiple presets so that multiple bitrates can be done, and you can just add some kind of a modifier so that each file will be separated based on that. So like for example, I want to create a low bandwidth thing, like I can select 360 pixel or 600 kbps option and then add any kind of a modifier. Then I can add another one like for the 4K users, or maybe like for high bandwidth users, I can select 108p or even more than that with 8500 bitrate option. So that preset can be selected. So I can add multiple, so that multiple files will be created on the output in the output folder. If you remember, as I mentioned, the IAM role, so that is another important aspect. So you have to select the IAM role so that the permission to access the S3 as well as to CloudFront and other services is provided to this job. Otherwise, the job will not going to run. So you have to provide the permission to this job to access the S3 storage. So the S3 is one of the aspects, but yeah, there might be different. You can have SQS as well. For example, when your job is done, you need to notify through the SQS through your backend, right? So your backend can make changes in your database or notify to the end user, whatever. So you can use different techniques to do that. Again, that can be configured under the job. So once this job is done, you'll see this under the job list, right? So under the media convert, you can click on jobs on the left side, and you can see so this job is now in progression state. So if you see like below jobs, I have already converted few. So this is once the job is done, you will see under the output folder, you will see these many files. So if you see at the last, so there is a Google Ads.m3 UAT, which is the last file, which is actually the main file, which will be given to the end user's player, which is browser or the mobile app. And this file has all the configurations needed for which like sequence of this TS files, how that can be played, the length and stuff like that. So these 4 files are actually automatically created by the media convert. So these are actually 10-second files. And if you see, each file is around 700 KB or so. So compared to the whole MP4 file, which was almost, I guess, more than 5 MB or so. So this is converted into smaller formats, and now these 4 files will be clubbed together in .m3 UAT, which is just like 200 bytes file, which is loaded by the player pretty quickly, parse it, and just play the sequence of TS files, which is mentioned inside the M3 UAT. Again, understanding M3 UAT is not a part of today's webinar, but I'll be covering in a future webinars as well. So this is how exactly the job is converted. So it's pretty straightforward. If you see just like 3-step process, I would say: create a bucket. Once you have the video ready, just click create a job and select a preset, and that's it. Your video will be converted within few seconds based on, again, the size. If it's pretty big file, like kind of gigabytes or so, it might take a couple of minutes or so, but usually it's pretty fast. So that's how exactly you can do it on AWS cloud. And to architect in better way, like for example, I'll give one of the example where in recent application, what we did, this was like kind of a meditation application which we built. In that, like there are a lot of videos the admin was uploading, right? So who was actually creating those videos, and these guys were creating in MP4. So they're uploading different format videos on day-to-day basis, and those will be uploaded through some kind of admin portal which were given, and directly through the S3. And as soon as the upload happens, we had a SQS, like simple queue messaging service, which was actually registering this job. And as soon as the video is uploaded and converted, the notification will be sent to the backend, which was actually updating the database and notifying the user that the conversion has happened. And now the mobile application was taking the M38 file instead of MP4. So that is pretty fast. So it was happening pretty within few seconds. So even the end user was not seeing any kind of latency. At high level, I'll show you how exactly the architecture works, right? The end-to-end architecture I'll going to explain you. So this is like kind of a last slide, but I want to make sure that you guys understood how exactly behind the scenes and what all different services one has to use when they are creating any kind of architecture. So this is like kind of a client where there are different roles, admin, user, who like your platform has. So we have to call AWS Cognito to authenticate, assuming that let's say admin is uploading your videos or the user. Then this admin uploads a using video and then app sync is used. I'm just giving some kind of service idea so that if you're building any kind of a video application, this can be handy for you guys to follow this architecture. But it's not like written on stone. You can follow your own architecture as well. This is generally like what I followed in one of the applications. So as soon as the video is uploaded and bucket, which I shown you earlier, we trigger a Lambda function, which actually um, just kind of written in Python, and that actually take care of updating some kind of a database. Like for example, once video is uploaded, it reads about the metadata and uploads in the DynamoDB, like what kind of file it is, the duration and whatnot. Then it actually starts a media convert job. So now it's automatic, right? So it updates the database for the metadata of the video, and then it starts a media convert job with the presets, with the input video that was uploaded and everything which I shown you. The media convert job, once it is done, it stores in the bucket again. So once that is done, again this S3 again calls the Lambda function, because now the video processing or the job is complete. Again, it calls the Lambda function, and then Lambda functions again like update the database with the new URL, because now earlier that was MP4, now it's M3U8, right? So the database has to be updated for the new video URL so that end users will get the latest URL from the database. So that's how the Lambda will be updated, updating the database, and then uh, through that uh, through that CloudFront, like CDN, the video can be accessed now, because CloudFront is already configured on the output bucket, and anyone now using that Amazon CloudFront URL can watch this video, download it, whatever things they want to do. So this is the kind of a high level architecture I had used in my past application. Okay, so this is what uh, I had for you guys for the in the today's webinar. So this is pretty high level, and in terms of the architecture, I was showing about using the video on demand service. Like kind of Elastic Transcoder is one of the important service that I was using, along with the S3 and CloudFront. So using these three services, you can create the video on demand platform pretty easily. Of course, the Lambda and stuff will be behind the scenes, but those are anyways you need in your application. But the transcoder, like Elastic Transcoder and S3 and CloudFront. This is one major services that I was using. If you guys have any questions, feel free to like just ask me in the chat box, and then I'll be happy to answer. Even you can reach me out in case of any questions later. My ID is Praveen@mindbowser.com. I'll be happy to help you out in your needs, like whether it's you're building any application, you want any architecture help, or you need any kind of a suggestions, you want to review your current architecture platform. I'll definitely going to help you out in whatever way you want on AWS as well as the video services. Thank you guys. Thanks for your time today. I hope you like the presentation, and definitely it's going to help you out in your future needs. Thank you.